Hi, in this series of videos, we will talk about proportions, percents, and gradients. In the last series, we talked about proportions and we did a little bit of setting them up, but I'm going to go through some more examples and I will also go through these examples in class. So if you miss class, then it's important to make sure that you're able to do problems of this sort. Okay, so let's look at the first problem. And these are just more proportions problems, setting up the word problems and making sure that we are identifying the important things. So it says the ratio of boys to girls in track is 5-4. Okay, so 5 boys to 4 girls. If there are 54 students in track total, how many are boys? So it wants to know how many are boys, and then it says be careful because there's a trick, and then it also asks how many are girls. So we want to know the boys, and then we want to know the girls. Well, it tells us the ratio of boys to girls. So if our ratio is 5-4, then that means that our total for the ratio is 5 plus 4, which is 9. So if we're comparing 5 to 4, so 5 boys to 4 girls, then that's a total of 9 track students. Okay, so now it tells us that there are 54 students in track and it wants to know how many boys are there. So if we're going to compare boys, we want boys to track students as far as a ratio. And so we want to compare boys again to track students. So this will be the actual total, right? So the actual total. And then this is where our ratio comes from. So we know that there are 5 boys to girls. Therefore, we have 5 boys to track students out of every 9 track students. And therefore, if we compare it to 54 students in track, then we have X number of boys. So to see what that looks like, and I have more room over here, 5 boys of every 9 track students, right, if we combine the boys and the girls, is equal to how many boys of the total 54 track students in this particular track program. So now we have our proportion. We have boys 5 to track students, and then we have boys again to total track students. Okay, so now what we can do is use our proportion and cross multiply to solve for x. So I'm going to solve for x by multiplying 5 times 54 is equal to x times 9, or we could write 9x. Okay, so I'm going to pause the video and allow you a minute to actually solve that. Okay, so the way we would solve that is when we cross multiply, we get 5 times 54, and if we want to get rid of the 9 in front of our x, then we're going to divide both sides of our equation by 9. But notice that I haven't multiplied 5 and 54 yet. Why? Because I don't have a calculator with me and I don't want to blow my numbers up. So what I'm going to do is I'm going to do some canceling to help me solve this. Well, I know that a certain number times 9 is 54. So what number do you think that is? If you guess 6, then you're correct. So what that means is 9 divided by itself is 1, and 54 divided by 9 will leave me with 6. So now I just multiply 5 times 6, and that will give me 30. So x is equal to 30. Therefore, now I can write the proportion 5 of every 9 students in track, so 5 boys of every 9 students in track, means that if I have a track team of 54 students, that 30 will be boys. And another way that I can check that is to reduce my equation, or my ratio. So if I reduce this by 6, so each one of these reduced by 6, then I would get 5/9. And so these check out and they are equal. Okay, let's try another proportion. Actually, no, we have to find how many girls there are. So if there are 30 boys, which we found, then 54 minus 30 tells us how many girls there are. And so we have 4 and 2. So if there are 54 students in the class, then 24 are girls and 30 are boys. So 30 boys and 24 girls will give you 54 total students. Alrighty, let's go to the next problem. Okay, so in this problem, this is a geometry type problem. It says a tall fence post casts a shadow of 2 feet long. So we're looking at our fence post here. So that represents that one. And this would be the shadow of the fence post, and it's 2 feet long. At the same time of day, so remember that in order for shadows to be in the same direction and the same size, it needs to be the same time of day. A flag casts a shadow of 21 feet long. So we're looking at the flag here, and this is the flag shadow. How tall is the flagpole? So notice that we're missing the height of the flagpole. Well, one thing I want to compare is height to shadow, to shadow length. And you can set this up any way that you desire as long as you're consistent. Okay, so height to shadow length. Okay, so if I do that, then the height of the flagpole is h, and the height of its shadow is 21 feet, which the problem tells us, and the height of the fence is 6 feet, and the length of its shadow is 2 feet. So you could also set it up as height to height and shadow to shadow length, or you could set it up as shadow length to shadow length and height to height. So it doesn't really matter as long as you're consistent in both figures, that the same corresponding sides are in the ratio. Okay, so now let's go ahead and solve this one. So how tall is the flagpole? That represents h. So h represents the height of the flagpole. I'm just going to go ahead and define that variable real quick. Okay, so when I do that, I end up with, I'm going to cross multiply, and so that's 2h is equal to 21 times 6. And notice again, I'm not going to multiply those out yet until after I divide by 2. So in order to get rid of my coefficient in front of the variable, I'm going to divide by 2 on each side, and I can cancel 2 and 6, and so that will be 3. And so now I know that h has a height of 21 times 3, which will be 63. And if I want to check that, then I can put in 63 over 21 is equal to 6 over 2. Well, how does that happen? Well, we could do it this way, where we could just cross multiply and see if the two ratios are equal, or we can reduce 63 over 21 or multiply out 6 times 2. So either way that will work. So 63 times 2 will be something 6. Let's see, 2 times, so 126. And then 21 times 6 will also be 6 times 1 is 6, and then that will be 12. So that will also be 126. So 126 and 126, that checks out, and so that's equal. Okay, let's do one more setup of a proportion problem. So in this case, we're comparing different units. So what we actually have are rates. So we can also use rates because a rate is a type of ratio. And so when we set two rates equal to each other, if we have two equivalent rates, then we also have a proportion. So Carol spends 17 hours in 2 weeks. So 17 hours in 2 weeks in a 2-week period practicing her culinary skills. How many hours, it wants to know the hours, so we'll call that X, does she spend practicing, or does she spend in practice during a 5-week period? So now we have 5 weeks. So we increased our weeks. Therefore, we can probably predict that the hours she spends practicing her culinary skills is actually going to be a larger number. And so we can go ahead and define that X as hours she spends practicing. Okay, so now let's cross multiply to solve this one and find the value of X that makes this true. Well, we have 17 times 5. So we have 17 hours times 5 weeks gives us 2 weeks times X. Okay, and I'm leaving my units in there for a reason, because I know that I have two different units. And so when I divide by 2 weeks on each side, 2 weeks, right? My weeks will cancel out in this case, and also my 2, so I'm left with X, and then my weeks will cancel out over here, and so I'm left with hours. So 17 times 5 divided by 2 is equal to X hours. So go ahead and calculate that. I'll give you a minute. You can pause the video. Okay, so you should have gotten 42.5 hours. Okay, and it's okay to leave that as a decimal. Because we're talking about hours, it's better that it's a decimal so that you can actually have a decent frame of reference or realistic frame of reference. Okay, so these are the only two that I'm going to do. I think after practicing these three, you should be able to do the rest of these proportions. And so in the next video, we're going to move on to percent proportions. All right, thank you, and I hope this has helped.